So we're going to start section 12.4, which is about tangent vectors and normal vectors. So we're going to start with tangent vectors, and I'm going to begin with the definition of what they are. So let's suppose C is a smooth curve represented by the vector r, vector valued function r, on an open interval I. Then the unit tangent vector which we're going to call T at T is defined as, so the formula for the unit tangent vector, it's going to be r prime over the magnitude of r prime, assuming that this is not 0. And remember that condition was part of being a smooth function, a smooth curve too. So let's look at an example where we're trying to find this unit tangent vector. So let's look at our example here. Let's find the unit tangent vector to the curve given by r of t will be ti plus t squared j when t equals 1. So the first thing I'm going to need in order to find our unit tangent vector is the derivative of the function r. So we're going to start by finding r prime. We're going to take our derivative. Derivative of r will be I plus 2tj. And then we're also going to need the magnitude of the derivative. The square root, 1 squared plus 2t squared. So the square root of 1 plus 4t squared. And now we're just going to plug this into our formula for the unit tangent vector t. It's 1 over the magnitude times the vector for r prime. So there's my formula for the unit tangent vector in general, but I wanted the unit tangent vector when t equals 1, so you're just going to substitute in t is 1, you're going to get 1 over the square root of 5 I plus 2j. And there's my unit tangent vector. It is a unit vector. Why is it called a tangent vector? Well, in order to see that, let's go back to our vector valued function here. It's ti plus t squared j. And so if we switch to parametric equations here, x equals t and y equals t squared, and if you plug in x in place of t, you'll get y equals x squared. So we're looking at the equation y equals x squared, which is our parabola. Here, centered with the vertex at the origin there. And if t is 1, we're talking about this point right here, 1, 1. And if we draw our unit tangent vector here with this base, with this initial point here, the unit tangent vector will be right there. So this would be t of 1. And so it's kind of the analogous idea of a tangent line, but instead it's a vector. It's a tangent vector and it's a unit vector.